Aloha, everybody. So this is going to be your quick review solutions guide for the target 12, 13, and 14, and 4.1 that we have here. So I'm going to run through this. You guys circle any questions or things that pop up along the way. Otherwise, this is basically just for you to check your answers so that we do not go through so much time in class. So I'm going to fill these in. I got 6.3, 4.7. If you need help with your calculator, please let us know before. I'm going to look into putting that Desmos calculator on the on the assessment. Sorry, trying to type in and go at the same time. So if you notice anything odd or off, let me know. If you get something else, that's good for you guys to make note of that and get help. So for first one, we got -4. We're at 6.3, somewhere in there. -3 is at about 4.7, about 3.6, about 2.7. 0's at 2, 1.5, 1 and a smidgen, just below 1, just above halfway. You're going to get something that looks like that. And I did one more. I like to test the outer boundaries sometimes, or at least get somewhat far out in case I'm a little concerned if this thing's going to keep going down or like that, or if it's going to level off. And I checked 10, and at 10 it also goes to 0.1. So again, if you could chop that into 10 pixels, it's going to be one of them. So yep, so this thing does end up leveling off and following alongside that. And it does blow up as you go to the left. So this is an example of a decay model. It's starting high and it's leveling off. The asymptote, they didn't ask you to find it, but if you did have an asymptote, that'd be right here at y equals 0. And that's also because there's nothing being added on to the outside. Things to note as you're looking at these problems, this is definitely also decay because my base, which is 3/4, is less than 1. So many things you can note just by looking at that formula. So this one, they left it open for you so you can plug in whatever you wanted. I mean, I did the standard 5, -1, I'm sorry, -2, -1, 0, 1, 2, and I did one more just to look over on this side, and you'll see why when we get there. Because at -2, I was at -0.25. At -1, I was at -0.5. At 0, I was at -1. Here I was at -2. Here I was at -4. So when you're just looking at this, that's a quarter, that's a half, that's 1, that's 2, that's 4. This thing definitely is blowing up, well, down, if you will. It's growing more negatively as you move to the right. And then as you move to the left, I checked -5. What did I get for -5? I got -0.03. So, I mean, that's as close as you can get. This thing keeps getting closer and closer and closer, but it does not ever cross. So this is a growth, but we would call this a negative growth. So this right here, the 2, that's greater than 1, so that's why it's a growth. This thing right here makes it negative, and for negative growth. There we go. If you wanted to check your asymptote, oh, I'm in red. I wanted to use the red for the asymptote. You want to check your asymptote, that's this line again, y is 0, because there is nothing being added on the outside over there. Next problem. Going back to blue here. So we got -2. So again, you can plug in any x values you want. I plugged in the standard 5, and then I plugged in a couple more as well. So calculator work, 1.5 to the -2 times 4 should give you 1.7. Here I got 2.6, I got 4, I got 6, I got 9er. So at 2, I'm at 9, then I'm at 6, then I'm at 4, I'm at 2.6, I'm at 1.7. So right here, I can see that it looks like it's going up to the right. And again, if you want, you can check values further down the line so that you can make sure. So I checked -5 and I got a half, or close to a half at least. And then at -10, I got 0.07. So about a half, and 0.07, that's less than 0.1, so that's going to be really close. So yep, this thing is a launch ramp. The asymptote, again, is at y equals 0. This is definitely a growth, and this is growing in the positive direction, so it's starting flat and then it shoots upward. Yippee. That's good. Next sheet. So here's the target 13. So here's our different scenarios. A is the initial amount. The initial amount is going to be this number out front, so I can fill those in really fast for all of these. 450, 206, 7,000. Easy. Or, well, you can see it right there if you know what you're looking for. R is your rate. So now here, one thing you can tell is that this is a subtraction, so that's definitely going to mean it's a decay. Now, how much it's being subtracted from 1 is your rate. So the 0.32 is your rate in decimal form. I think we ask it for you in percent form. So if you want to go from decimal to percent, you multiply by 100. If you want to go from percent to decimal, you divide by 100. If you wanted to, I mean, you could rewrite this as 450 times 0.68, right? And again, once you do that subtraction, you see that you're going to be at 0.68. That's definitely less than 1, so that is a decay model. And then if you plug in 10 for the time value up here, this is a little t, I got 9.5 roughly. So you started with 450, it's decaying, it's losing 32% every year or day or something, and then after 10 years or days, you're left with 9. For this one, they write it to you a little different. So this is 1.85. Well, 1.85 is greater than 1, so it's definitely a growth. So how much bigger is it than 1? Well, if you added 0.85 or 0.85 to 1, then you'd get to 1.85. So this is a growth by 85%. If you plug in 5, I got, so it's growing, it's going to get larger than 206. It actually gets quite larger. You're almost doubling it every time. 1.85 is almost double. I got 4464. So 4,464. For the last one, again here, you're adding 0.2, and 0.2 is actually 20%. So if you multiply 0.2 by 100, you get 20, or else if you shift that decimal over 1, 2 spots, you have to fill a spot in with a 0 there. If t is 3, you should get 12,000. Again, this is another growth one, so you're starting with 7,000 and you're getting bigger, so you should get something greater than 7,000. I got 12,096. 12,096. Moving on. I think we've done this one before. I remember Mr. K talking about the 40-acre plot of hunting land. So we got land that's valued at $200,000 right now, and the value is increasing at 5% each year. So there's your increase rate. The initial amount is 200,000, and it's increasing. Well, increasing means the rate is going up. So it's starting at 1. You're adding 5% each year. So convert that 5% to decimal. You're going to get 0.05. And 10 years from now, how much will it be? So you're going to do the exponent for 10. If you do that, you should get roughly $325,779. Making money. The population of the liger, number 5. Yeah, the liger, sure they exist, is estimated to be about 5,000. So there's 5,000 ligers right now. Oh, but the population is declining. Declining means they're going down. It's negative. So that's going to be 1 minus 10%. 10% is 0.1. Now, some people put the 1 0, and that's fine if you do. You don't need a 0 if it's at the end. How many would you expect after 20 years? So you'd have a 20 up in there. So the population is that, and then after 20 years, you get roughly around 608 or so. I think I rounded up for that one. Roughly 608 ligers. And that's 13 review. Moving on to 14. So describe in your own words domain. So domain makes you think of the x values, which are the inputs, and the x-axis runs from left to right. So when you're looking at domain, you're always going from low to high, and low on the x-axis is to the left. The range are the y values. We call those the outputs, and low to high on the range is down to up. How far low does your graph go, and how far up does your graph go? The asymptote, I've been saying that's like the bottoming, I don't even know if that's the word, bottoming out of your graph, or else if it's below the asymptote, or it's like the topping off point of your graph. And it's a horizontal line. It's an imaginary horizontal line that your graph approaches but doesn't cross. Bottoming out or topping off line. Yeah, that'll work. Next one. Oh, why is that red? I don't know why that's red. Okay. I missed a page. Here we go. So refer to this function. So is this growth or decay? Oh yeah, that's definitely decay. This thing is starting off tall and then it's leveling off. I also know that it's a decay because this thing right here is less than 1. So it's definitely decay. Domain. If you're looking at this graph, again, we're going to assume that these are endpoints here, that this graph will forever go up and left and forever go right. So the domain, how far left and right does it go? It goes all the way left and all the way right. So negative infinity to positive infinity. Your range is tied to your asymptote. So now we finally have, oh, we did this red line in class. So now we finally have this -4 sticking on the outside. So that -4 is talking about your asymptote. So that is where your graph will kind of bottom out at. So it's going to bottom out at, there we go, at y equals -4. So it's going to get closer and closer to -4, but it's never going to reach it. So that means the lowest point of your graph can be -4, or can be close to -4. We have an open parentheses because it's not going to reach it. And then if you go to the left and follow this path, it goes up, up, up forever. So it goes down to -4 and all the way up. The y-intercept, and that's somewhere right here. If we want to be certain, we'll plug it in. So for every y-intercept, we know that x is going to be 0. So if I look at my equation, remember that f of x and y are the exact same thing. So we're going to get y equals 12 times 0.35 raised to the 0th power. And anything to the 0th power is 1. So this is like 12 times 1 minus 4. 12 times 1 is 12, minus 4 is 8. And sure enough, that's right where the graph looks to be at 0, 8. Right there, bam. All right, last problem, here we go. So an antibiotic is being tested. So write the growth model for this one. So even though they're specifically asking us for 8 hours, we can just do the regular model for it. So we're starting with 10,000 bacteria, so that's how many we start with. And they are, the hope is that we're going to reduce or decrease the population of this bacteria by 50%. So that's 0.5 or 0.50 if you want. And then just the standard model would just be like to the teeth power. Teeth. So we got 10,000, and then 1 minus 0.5 is just 0.5. So next, what we want to do is complete our graph. So kind of like how we were doing this before, is we want to pick values that we can work. But now we got context in here. So we have to make sure that we're picking values that make sense. Like we can't plug in -2 because we didn't test this -2 hours ago. We start testing it now at the 0th hour, and we're moving on. So 0 is like when we started testing this population, you should get a 10,000 bacteria buddies. How you see that many buddies without them moving and grooving, I don't know, but that's just that. And then every year it's going to, or every, hour, it's going to hopefully reduce it by about half. So we can say, what are some of our expectations for this? So I'm just going to pick some values. I picked 5 values here. I guess I should have done 8. I'll do 8 as well. I'll do 8 at the end there. But after 1 hour, if we're going to lose half the population, you're going to have 5,000 left in. After 2 hours, if you lose half of that population, you'll have 2,500 population left in, or bacteria left in. So you can plug those in by doing the different values for T there. I went ahead and did 5, and I got 312, roughly 312, maybe 313 if you round that up. And then at 9, I got 19 and a half, so 19, maybe 20 of these things. There we go. So we can use that to get a graph drawn in here. So at 0, we're at 10,000. At 1, we're at 5,000. Look how fast that dropped down. At 2, we're at 2,500, right? So we're just going half the way, roughly. And then where's 5? 5, we're at 313. So these are going up by 1,000. So this is 500, and a little bit below is about 300. And then at 9, we were at 20. So yeah, that's getting pretty close to that right there. Oh, pretend that bump didn't exist. And there is the graph of this right there. So here we go, domain. So for here, the lowest x value we can go is 0. The highest is we could test this for theoretically as many hours as we want. So do 0, to infinity. What does your domain refer to? Well, here we're talking about the number of hours. So how many hours have passed since we started doing this, um, since we applied this antibiotic? Range. So what's the lowest amount of bacteria we can see? Well, you can't see negative bacteria, and you can see that this is getting closer and closer to 0. I wish we had a little bit more space in here. And then the most amount of bacteria, so it's always low to high. The lowest is 0, the highest we can get is 10,000. That's how many we started with. And the range is talking about the number of bacteria. That's what this value is over here. That says that's supposed to be a number symbol. The number of bacteria. Number of bacteria. Asymptote. So this is the lowest point of your graph, which we already identified in our range. This is right here. You're not going to get less than 0 bacteria. That doesn't make any sense. So that's referring to the meaning. What's the meaning of this asymptote? Can't have less than 0 bacteria. And our goal is to eliminate all those bacteria, so they're going to go away. And lastly, approximate the population after 8 hours. So you would come over here to your graph and say 8 hours and be like, huh, what is that value right there? If you plug it into a calculator, you should get somewhere around like 39 or so. And it's really hard to tell since this is supposed to be 1,000 units right there. But I do think you get around 39 or so if you're doing that right. All right, so there's your review solutions. Wow. If you have any questions, let me know. Thank you so much, and we'll see you in a second.